Hello, it's dumplet here. Here's an item on algebra. So we have a rational inequality here. X is a positive integer such that x minus 2 divided by x minus 3, it's less than or equal to 4/3. And we're asked to get all possible values of x. As usual, pause this video if you would like to give this item a try. But if you're done, let us dive into the solution. Alright, now for many of you guys, this might be a pretty simple question, but there's a common misconception that I want to point out here, which you guys should not be doing. Now this step is totally okay for equalities, but for inequalities, it's a different story because we're not allowed to randomly multiply. For example, in this case, we can use the cross multiplication, which is just in effect multiplying both sides by, well, for example, this 3 times x minus 3. Essentially, that's what I'm doing when I'm doing the cross multiplication. But here's the problem though. If the sign here was an equality sign, that's totally okay because we have the multiplication property of equality. But for an inequality here, it's not really the same thing because, for example, I'll be doing the cross multiplication, so 3 times x minus 2, and then 4 times x minus 3. Now, inequality don't really work the same way as an equality. The sign will actually flip if you multiply both sides by a negative number. And here we have the issue here because x minus 3, we are not really sure what is the sign of x minus 3. Now, yes, you can take cases, but that's going to be a whole different solution. So, well, for the equality sign, we just simply, for example, if this was an equal sign in the middle, then I'll just write an equal sign here, no problem. But here we have an inequality sign, the less than or equal to symbol. So we cannot immediately conclude if it's going to be less than or equal to or greater than or equal to without knowing what is the sign of this x minus 3. And that is the reason why a lot of people just cross multiply, retain the symbol, and in this case, if I solve for x here, I'll get x is greater than or equal to 6. Not that this solution is wrong, but it actually misses some other possible solutions. So it is totally okay in inequalities, but for inequality, we're going to do a slightly different approach. How we deal with polynomial equations, we put everything to one side. So quadratic, cubic, and so on. We typically move everything to one side, as you can see here, and we are going to kind of factor. But what we're going to do here is write this expression in terms of one fraction. So that is going to be the typical technique in rational inequalities. We are going to write this expression in terms of one fraction. Now, writing this in terms of one fraction, I'll be getting 3. The denominators, the LCM is going to be 3 times x minus 3. And the first term, x minus 2 here, becomes 3 times x minus 2. And then we have a minus 4 times x minus 3. So that's how we write it in terms of one fraction. And then the sign is going to still be less than or equal to, and then a 0. Now, a 3 times x minus 2, this gives us 3x minus 6. The negative 4 times x minus 3 gives us the minus 4x plus 12. So at the top here, we're going to get 3x minus 4x, so that's a negative x. Negative 6 plus 12 giving us a positive 6. And then the denominator is still just 3 times x minus 3, less than or equal to 0. And after we write it into one fraction, we're going to factor the numerator and the denominator. Now, luckily for us in this case, it's already in factored form. Well, we can actually do something better here. We can factor out the negative sign. So there we go. Now, we're going to treat this as if we are doing like a polynomial inequality, where we are going to write down the number line, and we're going to write down the critical points as well. Now, what are the critical points? The critical points are values of x such that these factored terms, so these factors in the numerator and the denominator, those are the values of x that are going to make those factored terms into to 0. So for example, in the denominator, I have x minus 3, and well, this technically, the 3, it's also a factor, but this can never be 0, so I'll just focus on the x minus 3 in the denominator, and in the numerator, I have this x minus 6. Now, if I want to make x minus 3 and x minus 6 to be 0, well, I'll have x equals 3 from the blue one, and then x equals 6 in the green one, and indeed, those will serve as my critical points. And Here I have only 2 critical points, so, but it's going to depend on the rational inequality you're working with. And then after we have our critical points, note how in this case we have 2 critical points, so it splits the number line into 3 different regions: values less than 3, values between 3 and 6, and values greater than 6. So in each of these 3 regions, we're going to choose a point for us to check. So for example, the less than 3, I'll try 0. The ones between 3 and 6, I'll try 4, and then probably 7 for the values greater than 6. And if the point I selected satisfies, then that region, then that entire region, it's going to satisfy. So for example, if I substitute 0 into this inequality, I will get negative of negative 6. So negative of 0 minus 6, so that's 6 divided by 3 times negative 3. That's going to become negative 9. And negative 6 over 9, that's definitely negative, so that's indeed going to be less than or equal to 0. So in this case, we know that everything in region 1, so it's going to work. So, well, x minus 3 here is technically a restricted value because of the fact that it's in the denominator. So it's going to be an open circle at x equals 3, but values less than 3. Because 0 here works, this part is going to be a solution. Now next we try the 4. If I substitute the 4 into this one, I'll get negative of 4 minus 6. That's negative of negative 2. So that's just 2 in the numerator, divided by 3 times 4 minus 3. So that's just 3 times 1. So 2/3. And 2/3 is not negative. So 2/3 is less than or equal to 0. That's false. So no solution within this region. So region 2 doesn't satisfy. So because of the fact that 4 doesn't satisfy. Now next we try 7. If I substitute 7, it's going to be negative of 7 minus 6, so that's 1, so negative 1, divided by 3 times 7 minus 3. Now 7 minus 3 is 4, 3 times 4 gives us the 12, so negative 1 over 12, that's negative, so it satisfies. So in this case, well, 6 works in this case, so 6 would have a solid circle to indicate that 6 is a solution, because, well, if x equals 6, the numerator is 0, which is indeed less than or equal to 0, and values in region 3, it's also going to satisfy. So this is how we solve the solutions to a rational inequality. So checking the signs, how we like what we do in polynomial inequalities as well. Alright, so now that we have the values for x, it's just a matter of writing it down. I'm going to write this in interval notation. This blue one represents, well, there's no lower bound, so it starts from negative infinity, and it stops at 3. The 3 is not included, so it's a parenthesis here. Here it starts at 6, so the 6 is included. There's no upper bound, so it's until positive infinity. And we have to join them with a union symbol. That's how sets work. So if we combine these two, we're going to get the following solution. So this was the blue one, this is the green one. We use the union symbol to connect the two. Sorry, to combine the two. Now, x is part of this, but as we recall in the given, we want to solve for x that are positive integers, so we just kind of list them all down. So in the blue part, well, the positive integers that satisfy is 1 and 2, because 3 doesn't work. But for the green one, there's a lot actually, so 6 is possible, 7 is possible, 8 is possible, and obviously all the positive integers from 6 up to positive infinity, that's going to work. So to sum up, to wrap up everything, the possible values of x that are positive integers will be 1 and 2, and everything from 6 to positive infinity. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!